Okay, so today's topic we have is scalar and vector. Once again, scalar and vector. So this scalar, it has only magnitude. Where is this vector? This is magnitude and direction. Example of scalar quantity can be mass. Example of vector quantity can be acceleration. Right? It can be distance, speed. Similarly, here in vector, it can be displacement and velocity. So though the unit of speed and the unit of velocity is same, unit is meter per second, and we have a unit of velocity is also meter per second, right? But how do we identify this is a scalar quantity or this is vector quantity? By seeing the direction. Example, if it is a speed, then we'll only say it is 5 meter per second. And if it is a velocity, then we have to say 5 meter per second due east. Since the direction part is added here, we can say that this is a velocity, whereas the direction part is not here. So this we can call this as a speed. So these are the very basic concept of physics. Similarly, moving further, there is a calculation of vector quantity. Calculation of a scalar quantity is pretty much easy because it does not have any direction. For example, if you add the two speed, then it is 5 plus 5, then it would be 10 meter per second, right? But it might not be the same with velocity because velocity has a direction. So we need to consider the positive and negative aspect. For example, if a man has a velocity in this direction plus 5 meter per second, right, and a same person written back in maybe 2 meter per second, then we have to present this as one is plus 5 meter per second and one is minus 2 meter per second. Why? Because of the direction. The value itself, the value is not negative, but due to the direction, it is negative. This is the direction part. This is a direction part. Okay, is it clear? Now, moving further, for parallel vectors. Or you can say you're finding resultant. Okay, for parallel vectors, that means there is a two case here. One is this. This is 5 meter per second. This is 2 meter per second. There's a case number B also, where this is 6 meter per second. Again, in same direction, this is 3 meter per second. Then the resultant vector for the case first. Resultant vector would be, any case, it is 3 meter per second in this direction. Similarly here, in case B, the resultant vector would be 9 meter per second in this direction. So here it is, here we have addition because of the same direction, right? Here with a different direction we have subtraction. Why this is the case? Because of its direction.
Oh.
Clear, right?
Yes.
Pop it.
Copied.
Now, let's come to the second part, that is perpendicular vectors. It is none other than 90 degrees, isn't it? While I say the perpendicular, it is 90-degree angle. So here is the first case. Maybe there is a two force acting in a right angle, okay? So this is 3 Newton force, okay? Force is vector quantity, so we can use here in vector. And this is 4 Newton. So in this case, the resultant would be its hypotenuse. This is also the triangular law, and the direction would be like this. Remember, you can always use an analogy like a person starts, okay? A person starts from this part. He starts to walk in this direction. He reaches this point, this cross point, and again reaches to top of the point. Since the vector is always the shortest path, we can say that this is the shortest path. The red double dotted line is the shortest path, so that this can be also mentioned as the resultant. So resultant vector here would be R. I can denote with R, right? You can give the direction also. And what is its magnitude? Magnitude, we'll use the Pythagoras theorem here. That is h square is equals to p square plus b square. And here we have R in h, so this can be done like 3 square plus 4 square, which would be 5 Newton. Now, the magnitude of the resultant is 5 Newton and the direction is upward from the point A to point B. So if the vector is perpendicular, then we have to do in this way. There is another case for this. What if it is a cyclic? Okay. Though here it is perpendicular, what if the vector is cyclic? This is the example of cyclic vector. Cyclic means like this. See, there is a loop inside, isn't it? There is a loop inside. A person move from one point to another point. For example, a person starts from point A, reaches the point B, reaches the point C, and again to A. Then what is the resultant value? Remember that when a person moves from starting point for example, A, and return to the same point, which is also known as that starting point is equals to ending point, then the resultant would be 0, right?
Oh, right.
Yeah, so the resultant of cyclic vector would be 0 Newton or 0 meter per second. And the unit can be anything. It must be vector. Since it is not given anything here, we'll not write any unit here, but also the resultant value we have is 0. So you can say that, therefore, the resultant of the cyclic vector triangle is 0.
Excuse me.
And this condition is known as, there is a special name for this condition. This is known as equilibrium. Now we know the one condition of equilibrium.
त्यो हजुरले के भन्छ त्यो when starting point becomes ending point resultant is 0.
Yeah, this is the case. The resultant is 0 when starting point equals to ending point.
The condition equilibrium फेरि भन्दिछौ न.
This is also the condition of equilibrium. The resultant of the cyclic vector triangle is 0.
Oh, okay. Why sir?
Good. Just a second, okay. Now, let's find the horizontal and vertical component of the vector. Finding horizontal and vertical component of vector. There can be multiple cases while finding this horizontal and vertical component. First, let's understand what is the horizontal and vertical component in the first example, in the first case. For example, this is some sort of force, okay, maybe X Newton, or this is a force. The horizontal component is always parallel to the ground. So this is the horizontal component. Suppose this is F, then we can say this is FH. Okay. And this one is here with a green line is vertical component. Let's denote this as a FV. And while finding the horizontal and vertical component of the vector, we also do have an angle. The angle can be in the vertical direction also, or the angle can be in the horizontal direction also. So let's have another diagram where we have an angle with horizontal part. So this is the force. This is the force F. And this is Fh. Fh is the horizontal component of the force. There we have theta. And this is the vertical component of the force. One more time. The vertical component is always parallel to the vertical part. So this is a vertical part, isn't it? This is a vertical part. Whereas the horizontal component is always parallel to the horizontal part, and this is the horizontal part. So why do we need to find the horizontal and vertical component of the vector? Since the every vector may not move in the horizontal or may not move in the vertical, may not move vertically. Sometimes it can move in both directions. So this example of A and B is the example where it is moving in a both direction. But you might have the other example also where it can move in a horizontal direction or it can move in a vertical direction. So this is the part, this is the force which is moving in the horizontal component, and this is the in the D part, this is the force when an object is moving in the vertical direction. So for this C, the vertical component is F, but the I'm sorry, it's not F, it is 0 actually. Sorry for that. The vertical component is 0, but the horizontal component is F Newton, right? So why it is 0 in C? The vertical component is 0 because the object is not moving vertically. It's so simple, isn't it? Similarly in D, now we can guess that vertical component of the force is F Newton, whereas the horizontal component of the force is 0. Why? Because the object is not moving horizontally. Simple as that. But in A and B, we cannot say that this is 0 or something like that because the object is moving in both directions, right? So let's consider the first example, case A, and find out the vertical and horizontal. The simplest way would be, if you want to memorize or if you want to be real quick, wherever the theta is, it is always cos. So you can say that FV is F cos theta. And the theta is not belonging to, or theta is not associated with the horizontal component. So FH would be F sine theta. So now we can find that the horizontal and vertical component in a real quick manner. Similarly, here in case B, FH would be F cos theta and FV would be F sine theta. But we might wonder that how we got cos theta or sine theta over here in case A. Similarly, in case B, it is different. See, FV has a F cos theta, but in case B, FV has a F sine theta. So we might get confused. For this, we need a derivation. Let's derive here, okay? So let's suppose that Fh moves upward and we can align this force like this. Okay, now this can be Fh, isn't it? We know that the Fh here and Fh on the top are the like vector. Yeah. So their value, the magnitude and the direction is same. So we can always move the vectors in this way. Now we form the triangle over here, right? So FV, we have the direction like this. FV, we have a direction like this. FV, we have a direction like this. Now see, it is becoming the vector triangle now. Now it is becoming the vector triangle. Now sine theta, what is a sine theta? Let's use some trigonometric ratio. Sine theta is P by H, right? Or sine theta is equals to, what is P here? In that triangle above, P is Fh and H is F Newton. Or Fh is equals to what I get? It is F sine theta. Similarly, you use a cos ratio. Okay, for cos ratio, cos theta equals to, this is B by H, and cos theta equals to, the B is FV and H is F. So FV equals to F cos theta. This is the second part. See, we got the same result that we remember before, that we used before. Okay. So it is easier to remember this one, but knowing this, after knowing this, it would be more easier, isn't it?
Yes.
If you get confused in an examination or while solving this type of question, you can still derive. You can put a little bit effort and derive the FV and FH and find the value. Similarly, here in this B part, let me drag FV over here. This is FV, right? And again use the sine and cosine ratio. That is sine theta is equals to P by H. Similarly, cos theta is equals to here B by H. Sine theta is equals to P by H. That means sine theta is equals to P is FV by H is F, and FV is equals to F sine theta. Similarly, for cos theta, it is B by H. B is FH by F, and FH is equals to F cos theta. We got the same result here, right? So this is equation first for the case B, and this is equation second for the case B. And for the case C and case D, I already said that in case C, we don't have any vertical component since the object is moving horizontally. So the vertical component is 0 Newton. And for the D, whereas it is the horizontal component 0 Newton because the object is not moving horizontally. The case A and B would be different. Got it?
Yes.
Okay. Copy it?
Wait, एकैछिन है.
तर त्यो एक्जाममा हुन्छ नि, एक्जाममा त प्रुफ चाहिँ सोध्दैन हैन?
हजुर.
त्यही भएर यतिकै जाने पनि हुन्छ चाहिँ.
भयो.
Okay. Now let's do this question. The diagram shows a resultant force and its horizontal and vertical components. The horizontal component is 20 Newton. So the horizontal component Fs, you can name it any variable. I write a 20 Newton as a Fh because this is the force and the horizontal component. So F stands for force and H is the horizontal component. So this is 20 Newton. Now the theta is 30 degree. And the question is asking about the vertical component. Let's try first, then after we will solve it.
So F it is F cos. So F is
okay. Let's suppose this is F. There are multiple ways to solve this question, but one of the way can be Fh is, we have formula F cos theta, right? So
yeah.
Fh we have 20 Newton, F and cos 30 degree. So with the help of this equation, we'll get F. That is F is equals to 20 divided by cos 30 degree. Once we get the F, then to find the F at Fv, which is a vertical component, it's easy, isn't it? Fv would be F cos, I'm sorry, it's not cos, it's sine, because the angle is associated with the horizontal component, so it should be sine theta, that is F sine 30 degree. Once you find the value of F over here, the same value should be in this equation F V. So what is the value of F in equation first?
23.09.
23.09 Newton. Now we substitute this value in equation 2, 23.09 Newton into sine 30.
So 23. 11.54.
11.54. Since this is an MCQ question and we have a solution here, 4 option here, and 11.54 is quite near to option number C. So option number C is the correct answer.
Yeah.
Okay, good. We did it.